Hello everyone, welcome to Ignite. My name is Vikas Rajput. I'm here to be the host for this session, and we have very amazing Michelle, who is going to talk to us about what is Azure Data. Now, before I hand over to her, just one call for everyone. We do have chat window and we do have chat moderators available. So if you have any questions during the whole session, please do not hesitate in using the chat window itself, and someone from our team will come back to you. With that, over to you, Michelle.
Thanks, Vikas. So good morning, good afternoon, good evening all. Welcome to Ignite if you're joining us for the first time. So my name is Michelle, and I'm an Azure technical trainer. And so today I'll take you through some Azure Data Fundamentals. So let's just start with the basics. What is data? Well, by definition, data is a collection of facts such as numbers, descriptions, and observations used in decision making. So I like to think of data as just pieces of information that you can gather from anywhere, and they can come in all different types and formats and different shapes and sizes. So just before we jump in, I want to talk about some of the roles that you can find in data. So, in the typical data team, you might find someone who's a database administrator. Now, their job is really to, manage the databases, implement data security, do backups of their databases and updates, control who gets to access their data, as well as, monitor the performance of their database. You might also find data engineers in your data team. So these are the people who build data pipelines to process the data, transform the data, ingest data into storage, and really prep or prepare and nurture the data so that it's ready for analytics. And then you might also find data analysts. And so these are the folks who provide insights into the data. So they might perform some visualizations on the information that you've turned your data into, and they create these nice visual reports and dashboards that they can share with the rest of the organization. They might model the data for more analytics, and essentially they're the data visualization components. Now, not on the slides here is also another role called the data scientist role, and a typical data scientist takes data and trains the data on machine learning algorithms to build machine learning models. And these machine learning models are what's exposed as AI services that we might know of today. Now let's have a look at the journey that data has to go through to turn it from the raw data that we collect into insights and information. And it's quite a journey. And I know that this slide seems a bit scary at first. It did throw me off a little because I saw this and I was like, oh, there's a lot of components involved. But that's okay. We're going to go through it sort of step by step. So let's just get started. So, where does data come from? So the data sources stage. Well, I mentioned before, data can come from anywhere. It can come from your point of sale systems or your POS systems. It can come from your end user devices. So these are things like your mobile phones. It can come from IoT devices and sensors. So these are things like, your smartwatches, that I've got one on my wrist, your smart TVs or smart lights or smart fridges that you might be running in your house at home, or come from your online transaction processing systems. And these are things like databases that organizations use to process their transactions on a day-to-day basis. Now, data can come from anywhere. So once we've identified our data sources, we probably want to either store it somewhere or stream that in to do analytics and processing. And so typically when we talk about collecting data, we talk about, either collecting them in batches. So this is, we've got lots of data and we just want to collect them into one common place as a staging environment until we figure out what we can, do to process it later, or we can stream data in. And the distinction to make here is some data is coming in at such a high speed, such a high velocity that you really want to process that in real time. And so we talk about real time real-time data, streaming and real-time data processing, because often, if we're, say for example, if we're collecting data from our IoT devices and sensors, we want to stream that in and, do a bit of processing and then visualize that all in real time. And so if we're talking about data collection, batch data collection, we've got a couple of solutions that you can use in Azure. So we've got Azure Blob Storage or Azure Data Lake Storage. Now, Azure Blob Storage, for those who might not know, blob stands for binary large objects. And so a blob can be anything. A blob can be an image file, a blob can be, video file, or audio file or text file. So you can chuck anything into blob storage. Azure Data Lake Storage is sort of an extension on blob storage. So with Azure Data Lake Storage, you kind of define a hierarchical system to store your blobs. So think about your computers. You have to define the folders to store your files, and that's a hierarchical sort of file system, storage. If we're talking about streaming data in real time, so the real-time streaming, we can use things like Azure Event Hub. So Azure Event Hub allows you to, stream in events from a bunch of sources. So, an application might emit some events. So if you've ever received a notification on your mobile device, which I'm sure you probably do often, that's because some application somewhere has, emitted an event, and it's notified you via your mobile device to go and check out that event that's been emitted by the application. So those are events. Now, Azure IoT Hub is an extension on Event Hub. So you can use Azure IoT Hub to connect to your IoT devices and really, do bi-directional communication between your IoT devices and Azure. So you can, say, for example, send the sensor data as messages from your IoT device up to Azure, the cloud, or you can, send messages down from Azure back down to your IoT devices to maybe communicate some action to take. So for example, if it's a smart light, maybe you want to tell the light to go turn on, for example. So once we've collected the data, or we've streamed in our data, this is the processing and the data analytics stage that we get into. So now that we've got our data, we've streamed our data, and we really want to process that, transform that data, so that we can turn it into something usable for our data analytics workloads, and really tune that into information and insights, essentially. So again, if we're talking about batch data processing, we can use things like Azure HD Insight. Now, what Azure HD Insight is, it supports all the open source data analytics frameworks that you may or may not have heard of. So things like Apache Hadoop. So let's say, we're dealing with so much data, right? So we've got a very large data set, and how do you process all that in one go? There's no single, computer or machine that exists on planet Earth that can process that in one go. And so with Azure HD Insight, what you can do is write MapReduce jobs and submit that to a Hadoop cluster. And so if you don't know what MapReduce is, essentially, if we've got this large data set, we can break this down into smaller chunks or smaller data sets, and then we can submit each chunk of data to a cluster of compute, a Hadoop cluster, and then get that to process it. And we can do this all simultaneously in parallel at the same time. And so that's called massively parallel processing, or I think the acronym's MPP. And so you can imagine that, doing massively parallel processing, we're imitating this large machine or computer, the supergiant computer that we have, to process our large data set all at once. And so, once each cluster or each chunk of data has finished their processing, we simply just, combine, or the reduce stage of MapReduce, combine all the results. And that's your, big data analytics job done. The other component that you could use is Azure Data Lake Analytics. So Azure Data Lake Analytics, for example, you can take the data stored in your Azure Data Lake storage, and then you can define your data analytics workload in a language called USQL. So USQL is a hybrid or a combination of C# and SQL. And so, once you've defined your job in USQL, you submit it to Azure Data Lake Analytics, and then Azure Data Lake Analytics figures out the best way to run your analytics job. Now, if we come down to the real-time data streaming and data processing, we've got, again, Azure HT Insight, which supports some of the open source real-time processing frameworks like Azure Apache Storm and Apache Spark, or you can use the Azure service, so the Azure Stream Analytics, which supports that real-time data processing. Now, you can also take this data that you've collected and you've stored, and train machine learning algorithms, or build machine learning models with it. And so we can take this data and we can feed it into machine learning algorithms, and then train that into models that we can essentially service out as AI services. And you can combine that with Azure Databricks, which is a data analytics platform that you can use to process the data and really prepare that for your machine learning workloads. And you can do your machine learning workloads in Azure as well. So you can use Azure Machine Learning Services, which is kind of a workstation or a workbench for data scientists to run their machine learning workloads. So they can spin up a whole bunch of resources that they need for their machine learning workloads, like compute and storage, and a whole bunch more to allow them to build their pipelines, their machine learning pipelines, and essentially expose that out as a model that applications can consume. Once we've done all the processing, we've done all the hard work, or at least your machines have done all the hard work, you probably want to store that somewhere. And so we want to store it in a data analytical store. And the one that we have in Azure is Azure Synapse Analytics. Now, Azure Synapse Analytics used to be called Azure SQL Data Warehouse. The reason why it's not called that anymore is because we've taken Azure SQL Data Warehouse and we've added a couple of analytics capabilities to it. So now, you can run your analytics jobs, by spinning up SQL pools and executing your data analytics jobs in SQL, or by spinning up Spark pools and executing your data analytics jobs in Spark, on top of the data that you've got in your data warehouse in Azure Synapse. And so, once we've done all our analytics and all that kind of stuff, we probably want to present this information and insights that we've gathered from our data analytics in a very visually pleasing way. And so the service that you would probably find most useful for this is what's called Microsoft Power BI. Now, Microsoft Power BI is a data visualization tool. It's not only a data visualization tool, it's also a data analytics tool. But with Power BI, you can create dashboards, and this dashboards could have really nice and pretty bar charts and pie charts, and all the visualizations that you often see when we're presenting data back to maybe the executives or the board of directors, or the main stakeholders or business decision makers of the business. And so you can use Power BI to do that, or you can also use Azure Analysis Services. So Azure Analysis Services allows you to really slice and dice your data so that you can, kind of view your data in different views or angles to really, do more analytics and also visualize that as well. Now, it's great that we have all these components to support, each stage, from, the data sources to the data storage, to the processing and the analytical data store, and, analytics and reporting. But how do we piece this whole thing together? And there's a service called, and you should keep this in mind, called Azure Data Factory. So Azure Data Factory, or we say ADF, is a data ingestion, integration, and orchestrator tool that you can use to, for example, ingest data from your data sources, store that somewhere, and apply some transformations to it. So you can filter your data, you can clean it, you can do, aggregations and join data and all that kind of stuff in Azure Data Factory, and then you can sync it into a storage like Synapse or maybe Cosmos DB. So Cosmos DB is our NoSQL database offering, or other storage like Blob storage or Azure Data Lake storage. And so Azure Data Factory helps you sort of orchestrate and facilitate that entire data process by allowing you to build these data pipelines that you can execute and run in Azure Data Factory. And well, now you might be interested in, how do I take my Azure and data learning journey further from this session, I hope. And so if you're wondering that, then we've got two great courses or great training events that we have on offer. So the Azure Fundamentals Certification and Training Day, as well as the Azure Data Fundamentals Certification and Training Day. So the Azure Fundamentals kind of takes a look at basics of cloud and the basics of Azure. So it's typically a 1 to 2 day course. The Azure Data Fundamentals training or certification is really a 1 day expansion on everything that I just talked about just then. And once you've done your fundamentals and you want to continue further with your data journey and learning path, there's a couple of certifications that you can sort of pursue further. So depending on where your interest lies, so if you're more of a SQL database, or you come from a database background, or if you want to go deeper into databases, then the Azure Database Administrator Associate as well as the Azure Data Engineer Associate certification is definitely the one that you should be checking out. If you're more interested in pursuing machine learning, data science, and all that kind of stuff, AI further, then I would say check out the Azure Data Scientist Associate certification. We've got more learning resources as well. So the one that I want to mention is Microsoft Learn. So Microsoft Learn is a great platform that you can freely access. Contains a lot of content that aligns very closely to the courses and the certifications that we have on offer. And the best thing is it's self-paced learning, so you can jump on anytime and start your learning journey anytime you want. We also offer training events that are instructor-led, and so the fundamentals that I mentioned earlier, they're typically 1 to 2 day training events that you can take, and we take you through all the content for those courses. And finally, so at Ignite, we've got a Cloud Skills Challenge that we are running. So just by signing up and joining, you get to earn a free Microsoft certification exam that you can sit, and they typically cost quite a bit of money. So I would definitely, sign up if I were you. And the exclusive chance to win some experiences on Microsoft Learn. So if you want to go sign up, go to myignite.microsoft.com/learning-zone. And if you want more resources to help get you started, then I would suggest starting with the learning path for Data Fundamentals. The link is on the slide. And don't worry if you didn't get all those other links before. You can download the slide deck after Ignite session finishes, and sign up for our virtual training day that we've got coming up. So I'm hoping that I'll get to see you there. So with that, I think we've got a couple more minutes for some Q&A. Vickers, is there any questions from the chat?
Sure. Thank you, Michelle. That was really amazing. Yes, we do have some interesting questions coming through. So first one I'll pose to you. Mm-hmm. Since you mentioned about Azure Data Factory, or ADF for short, how will you differentiate ADF from something like SQL Server Integration Services, or SSIS?
Okay, that's a good question. So SSIS, or SQL Server Integration Services, for those that don't know, it's the sort of ETL tool that's sort of been out in the market for quite some time now, and typically use sort of on-premises to do ETL, so extract, transform, load workloads. So for example, we might extract some data from your SQL databases, do some transformation to it, and then load it into a data warehouse. Now, Azure Data Factory, or ADF, people think that it's the sort of cloud equivalent of SSIS, but it's more than that. ADF is a data, orchestrator tool, and so not only can you ingest data using ADF and do a bunch of transformation and load it, with ADF you can also plug it into a whole bunch of different Azure products and services, like I mentioned before, Cosmos being one of them, Azure Data Lake Storage, Azure Blob Storage, and a whole bunch more. So yeah, ADF is sort of a more robust orchestrator tool that runs on Azure. So I would say those are sort of the main differences.
All right, so the next question also for you, Michelle, is how does Azure helps me with data governance?
Well, that's a big question. So yeah, data governance, I mean, there's a whole bunch that we can cover here. So for example, when we're talking about data governance, you probably want to think about, who can access my data, what my compliance requirements are, and all that kind of stuff. And so let's talk about user access, right? So we can use Azure Active Directory, which, with the role-based access control, so RBAC, you can define, who gets to inherit, access rights by defining, what sort of roles they inherit. So for those who are not familiar with Azure Active Directory, it's our identity management platform. So you can do things like, authentication, which is all about, identity verification, and authorization, which is granting access rights. And so, defining really using role-based access control, defining roles in terms of who gets to access my data, and not only who gets to access my data, but also the data services that, those data sits in and runs on top of. What else? Vikas, you want to jump in and give your input?
Sure, I think that's definitely a great start. Thanks for that, Michelle. If I may, I would also add some more foundational services here, actually, knowing that this is more about data governance. I would probably go and look at services like Azure Security Center and Azure Threat Protection, which could actually be quite intriguing and quite revealing in this kind of scenario. Azure Monitor is another great example of service that I would probably go and keep my eyes on just to see what's actually happening in my business. When it comes to implementation, when it comes to enforcement of some of these governance principles, Azure Policy is another great example of the service which I can use for things like, where do I want to place my services in the world, in what region? So I could really go and put that out as my policy definition, just to make sure that even by accident, my team is not going and placing data services somewhere other than where I intend them to be doing it. ARM templates is probably another great example in doing this automatically. If you are going towards infrastructure as code, and you should, in that scenario, I think ARM templates can be a real great advantage. And you can really control what's actually happening in the business. And on the same note as well, I think automation, Azure automation itself can be another great example to think about. For example, we have a concept of desired state configuration, DSC. I'm happy for you to go and explore that a bit more if you like. And that actually really helps us in defining what the governance should be like, how the policies and procedures and services should be stood up, and whether or not they actually are still standing with that security posture, that governance principles. So with that, I think I'll I'll go and wrap up with say, okay, these are some of the considerations when it comes to data governance. So the next question, Michelle, if that's okay, I'll probably take that next question as well, knowing that I'm still in the limelight right now, just to steal a few more moments away from you. So the next question is, how Stream Analytics is different to Azure Databricks? And the way I will look at it is Stream Analytics is a fully managed cloud service, obviously provided by Microsoft and things like that. It has its own query language, which we call upon as SAQL, which is a lot SQL-like, and it's no fancy name. It's just an acronym for Stream Analytics Query Language. But the notion and the way the Pragma works and everything is slightly different. And as I said, this is all fully managed service as well. Databricks, on the other hand, it's a full-blown clustering service that you can really provision and kill it and reproduce it as the way you want to go. So that way, Databricks is quite good. Another good advantage with Databricks is that it has a couple of different modalities in which it can operate. So obviously it can accept streaming data. So Stream Analytics deals with streaming data alone, whereas if you look at Databricks, it can deal with streaming data and few more data types like SQL and key value pairs and those kind of things. But as I said, I think from the overall perspective of how these services will be stood up and how they can be managed, Databricks is quite a lot wider in scope versus Stream Analytics. All right. So with that, I'm just looking back. Anything else that we might have? Yeah, that's the only questions we have for now. Look, if that's the case, I'm happy to go and wrap up now, and then do want to say thank you to everyone. It's been great to have you. You have been really amazing and engaging audience. Have been asking questions every now and then, which has been great, and that's what we are here for. I hope you enjoyed the session, and I hope you are looking forward to some more sessions today and on the subsequent days as well. It was a pleasure to have you. Have a good day.